All right. I think we are on. Let's see. We have 2 viewers so far. That's awesome. You're all welcome. Feel free to throw anything on the chat. Let me know that you are hearing me properly. Okay. Today we are going to talk about KEDA. Before we start, I just wanted to make sure that this is a stream, right? So anything can go wrong. It's not a presentation. I'd love. Oh, awesome, David! Thank you so much. So this is a stream. We are doing this together. I will make mistakes. I'm 100% sure. I'd love you to contribute. Ping something on the chat. Ask, object, correct me. That'd be awesome. So let's begin. But before we talk about KEDA specifically, let's talk about Kubernetes scaling. It helps to switch to the whiteboard. So, what does KEDA solve? Kubernetes without KEDA, let's draw something here. Let's assume that this is Kubernetes. Usually you will have pods running at a time. Maybe say it's a one pod. In Kubernetes, it's intrinsic. There's an intrinsic way to make sure that your pods can scale if required based on resources consumption. So if your pod is consuming a lot of CPU or memory, you know that there is a load on it, then you want to create another one to distribute the load. How does this happen? Usually is through something that we call horizontal pod autoscaler. The horizontal pod autoscaler, it consists of a controller, the controller of the horizontal pod autoscaler, and an object that you define the characteristics of how you want the autoscaler to behave. So let's imagine that you have this pod X. In your object, you create a CRD object. You say an HPA object. You say for pod X or deployment X, if the CPU reaches 50%, I want you to scale out. You create this object. The controller looks at these HPA objects that are created and says, all right, fair enough. I'm gonna keep an eye on the pod resources consumption. If we reach 50% of a pod, I will instruct to create a new pod. If also this is not sufficient and we still are receiving 50%, if every 15 seconds, I think every 15 seconds, the controller will check, is still the CPU 50% is being consumed? If yes, then scale again. If not, then if it's less than a certain threshold for a period of time, then it will start taking them off back to scale 1. This is something that exists in Kubernetes without any need to any external power. Now, the problem with this is that the metrics that we are depending on to scale out or in are resources that are regarded in the pod itself. It's how much the pod is consuming as CPU process or memory. This is the first issue. The second issue is that you have to have at least one pod in order for HPA to look at your pod and see if it's consuming a lot of CPU or resources or not. Fine. Now, what if something else happens outside of your cluster that you know that is going to affect your pod? The most basic and straightforward example is if you have a queue of messages and your pod pulls these messages from the queue and process them. If you have a very long queue, you want to make sure that you scale your pods accordingly. The problem is this is an event is outside of your cluster. It's not a CPU. It's not a memory resource matrix. Luckily, Kubernetes created APIs to allow external parties to query this for you and feed it to HPA so that HPA can scale out. So this is where KEDA comes. KEDA solves two problems. The first one is that it provides what it's called a metric server. The metric server, you can configure Kubernetes, you can create a controller or a pod, and you configure Kubernetes to use this as a metric server so that Kubernetes can ask the metric server, do you have any metrics for me? And then it will, this metric server, let's say it's KEDA, it has the logic and the knowledge on how to ask how big this queue is and return the result to the HPA so HPA can scale out. Awesome. Following me? Oh, we'll have 5 viewers now. That's good. Now this is the first one. KEDA provides a metrics server. The second issue is that in the HPA, the one that comes with Kubernetes, scaling from 0 to 1 or from 1 to 0 pods is not supported. You can't scale from no container to or no pod to at least one pod. This functionality, this one and this one, is also taken care of by KEDA itself, at least for the first container. Once the first container is created, it's delegated back to Kubernetes through the HPA controller to query the metric server in KEDA for any resources. But how does this happen? KEDA provides something called scaled object, a CRD as well. Scaled object. In the scaled object, you define the properties that will allow KEDA to create this object, and configure the specific scaler to know how to get the metrics. Things like the connection string, a connection string for a database or for storage, key value pairs, it will use the information in the scaled object to be able to configure the small scaler to retrieve the information. And also to provide the thresholds, like for example, if the queue is, if there's more than 30 items in the queue, then increase the pods. This information will be translated to an HPA object that will be monitored by HPA to query the metric server and scale accordingly. It's a bit of a dance. It's not too straightforward. I think I have some gray hair grew here due to reading a lot of code and documentation, but at least this is at least my understanding. Cool. Feel free to throw anything for questions or comments. Now, enough theory. Let's dig into the live thing. Let me put this away. Bring the keyboard back. Right. If you want more information about the horizontal pod scaler, you can check the documentation on Kubernetes. This will give you a little bit more information about the horizontal pod scaler itself. You will not find too nice information about the external horizontal scaler. Nonetheless, this is what we are trying to do ourselves today. There's also more information in this page where you have walkthrough with a little bit more details on how to construct an HPA object that will be used to scale the pods. All right, so here's KEDA. KEDA, we'll look at the code shortly on our machine, but if you look at the source code itself, you will find that in package, in scalars, you will find several scalars that come with the source code already. Things around like a scalar for AWS CloudWatch, scalar for monitoring or scaling based on AWS SQS queues. You can see Azure Event Hub. You can see a scalar based on Azure Queue, Kafka, Redis. There's a lot of scalars out there. All right. The first thing we want to do is to clone this to our system and start coding on it. To do that, we have to fork it to my account, which I did earlier. And you can see here that we have this fork. We will clone it and start working from scratch. One of the things I wanted to point is that this diagram that is very close to the diagram that we drew earlier on the whiteboard. So clone, let's do this. I don't want HTTP. Clone and download. I can get this. There used to be an option for the HTTPS. Do you remember? Use Git to check out. Doesn't matter. We can figure this out. To be frank, I already cloned this on master, and in a folder I called KEDA-ASCII, and we can open it with code. Here you will see that we have the place where we want to check where are the packages, package and scalers. This is our playground. It goes without saying that KEDA is built on Go. So in order for you to build a scaler for now, you have to know some Go to be able to build a scaler. Now, having said that, I know from the roadmap of Microsoft and the guys who are building KEDA that there will be a way to create scalers out of KEDA itself. Now, the only way for now to create a scaler is to get the code, create your scaler, bake it in KEDA, deploy this newly baked KEDA in the cluster, and it becomes part of KEDA. This is not going to stay for long. Nonetheless, we're going to build it this way, but until the official way of enabling a dynamic scaler to be deployed in the cluster, and then KEDA finds the magic through gRPC to communicate with a scaler, until that way of creating scalers is finalized, we will have to be developing our scalers within KEDA itself. Before we change anything here, I think it'd be good to just build KEDA itself without any changes. Pick an example based on the simplest example, like RobotMQ. This is the most common example in presentation they are doing to demonstrate KEDA. And we make sure that our own image that we would create from our source code is running nicely in our cluster. Cool. But before that, if I go back to the documentation, this is something is recent. KEDA, before maybe 2 or 3 weeks, it was not built around the operator model. Recently, this has changed, and now if you look for Kubernetes operators, you'll find some documentation around what is Kubernetes operators and how they work. In a nutshell, an operator is a way to package an application to run in Kubernetes and to be smart on how to run and make sure that the application is healthy, because it will involve different pods and different services. With an operator, if you package it in a certain way, you will be able to run this application in a consistent way. For that, we need to install. If you scroll down, this is part of the documentation that was recently changed. That we need the operator to be installed, the SDK operator. This is my one. It's a little bit oldish. If we check the new where did it go? If you go the new master here, you'll see that you'll see what? You'll see that in the documentation that we have changed, the guys have changed I'll make you dizzy, I'm sure. I'm sorry. Sorry, just hold on. Deploying custom KEDA. There's some magic here. One of the things that we need to make sure is that you install the operator SDK framework. We have to, in order to build operators in a convenient way without a lot of manual intervention, we can use the operators SDK to create proper operators. And this is what KEDA team did. They used the operator SDK to build and package KEDA. Now, which operator SDK framework version should we install? Because if we check here in the releases, you'll find that there is several versions. You want to make sure that you install the right one. How do we know this? You'll see that in tools/build tools Docker file, which is in you know what? I think I should update my code base. All right, maybe you'll enjoy this. I hope you enjoy this. It's just some Git trickery. So when I cloned my code from my GitHub fork, so if I cloned, where did it go? There you go. I cloned this guy, my fork of the KEDA. Yeah. So when I cloned it, if I check the remote, you'll see that the origin is my fork. But because I wanted to keep sure that I'm updating my repository and from whatever KEDA recent changes, I added another remote, which is KEDA core itself. Yeah, so I can follow up on the changes. Now we will be on the bleeding edge right now. So this is my master. So if a very nice tool I love is git k. If we want to see all the branches that are there, you'll see this is master, my local branch. It matches the remote's origin master, which is my fork, but you'll see that KEDA core master has really sprung a lot there. There's a lot of commits there, not too much, but there's a lot. Sorry for this. In order for us to be up to date with that, I think we need to merge. The good thing is that merging from here to there is going to be straightforward. Yeah, there's no branching too much, so it's just like fast forward. So let's do this. First of all, we have to close this. Git fetch all, just to make sure that we are getting all the remote branches. Am I boring you with Git? Please let me know if it's part of the process. Yeah. So we are up to date. Now we git merge with origin, but not origin, sorry, KEDA core master. Voila. Because it's fast forward, that was pretty fast. If I open git k again, you'll see that master is matching the remote master in KEDA. You can see that the origin master is not up to date. We have to push this guy to make sure. Close this. Git push. Now my fork is being updated to be an exact match of KEDA core master. Now we are on the bleeding edge. Terrifying. Okay. Back to the operator thing. Which version of the operator I should install on my machine? if we check tools, sorry, I keep jumping fast. If we check tools, and the Docker file, if we look for the release version, because this Docker file builds the tools image that will be used to run KEDA in the test pipeline in the workflow. I'll show you in a minute. Just let's find that. Oh, copy, paste. Yeah, so it's release version 12. So when you clone your code, make sure that you check this one so you can install the operator SDK that matches this one. Having said that, there's a wonderful contribution that says building a quick start with Visual Studio Code remote using containers. And this is amazing. This has been, if you heard about Visual Studio Code, you can use containers to load your code inside that container and run all the tools inside the container without installing anything on your machine. I'm a little bit nervous about this, just for the lack of trust in myself, if I can say that. Maybe next time I should do this. Nonetheless, I installed the operator on my machine to just be as close as possible. So, how did we know that this happens? Let's check what is called the make file. Let's minimize. Oh, I want make file. All right. In the make file, it's I'm new to this, yeah. So there's different like we have in the .NET world we had MS Build. We had in the older days we had Nant. Java, I think they had Ant. It's make is very similar thing. It's a way to build or execute steps based on dependencies to compile the code, maybe build images, run unit tests and stuff like this. So KEDA uses make. The thing that we are interested in is not all, is not test, is not publish, absolutely. We are interested in build. In build, there's two steps. There's the build adapter and the build controller. We don't have to go into too much details in this. The only thing that we need to have a look at is that we are executing the operator SDK to build. So we have to make sure that it's installed. And you can see that we are using environment variables defined to tag or to run properly. So whatever environment variables we have, it's going to be used in the build system. So this is to build the controller. This is to build the adapter that will eventually be after building the controller and the adapter. This is the bit that is the most interesting. The interesting part is that once we compile our code, we will Docker build an image from the adapter Docker file and tag it with the environment variable image adapter. So in the command line, if I'm in the right place, I think I am. If I say make build, we will execute the build step, and we expect an image is created. But before we do this, let's see Minikube, because I use Minikube. Docker desktop is amazing for Docker, but for Minikube, I don't really enjoy it. I like Minikube more. I feel like I have a little bit more control of it. There's more choices for the drivers and stuff. So I use Minikube. The Minikube, I have one that is running Minikube. Now I can configure my Docker CLI to talk to the Docker daemon or daemon in the Minikube itself. To do that, I invoke this command, Minikube. So if I run Minikube Docker environment as this command by itself, you'll see that I'm changing the environment variables that Docker uses, the Docker CLI to connect to the Docker daemon. So this is the IP address of my Minikube cluster, and you can see that there's a certification path and stuff like this. So if I run eval Minikube Docker environment, now if I say Docker ps, you'll find that I'm loading all the images that are in my Minikube cluster. Now that my Docker environment is ready and my Minikube is ready, my cluster, you can see that there is no reference. There's no image for KEDA at all. It's clear. It's a clean image list. Let's copy this environment variable and give it a value. Export this guy to equal. Where is this now? Export. Oh yeah, there was adapter. Let's say imad KEDA. What do you think of this variable? I think it's good enough. Now if we echo image adapter, imad KEDA. Now if we run the make build run, now we are building KEDA directly from our code, and hopefully once we reach the Docker build command, it will pick up the environment variable and will build an image for us that is tagged by our own tag. Now why would I do this? The reason why we have a different tag or a specific tag is if I tag it with latest, it will be confused by the image that resides in Docker Hub for KEDA. When I try to build, there's an error, I was distracted. Let me just finish the statement. When I build the image, the KEDA image, and deploy a KEDA to my cluster through the operator, Kubernetes will from this deployment, we'll try to pull the image from Docker Hub, and it will conflict. So you want to tag your image specifically so it's not found in the Docker Hub. Now, why did we have a failed output? Let's see. Now this is your chance, people on the chat, to come and have a look with me and build this together. All right. Copy failed. The var docker builder output being KEDA, no such file or directory. Failed to output build image docker KEDA core. Failed to execute string docker build minus something 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 exit status. Failed to output build image docker. This is a weed. I think this is the price of running on a bleeding edge. Let's try it from here. I'm not 100% sure if I am on the right branch. Is it the same? Yes, I think it's the same. Echo. Oops. Is it that? Echo. Yeah. Isn't it current directory? Maybe it's echo. Yes. Source KEDA ishi in here. Echo. It is. It is indeed. This is weird. Let's close this and see what happens. Clear. Make. Build. You know what? Let's open make again. Make file. In the build part, we are getting it from image adapter. Yeah. Let's try this again. We are in master. We are in the root. Make build. Let's echo the tag again. Image. What was it? Oh. Git make file. Yari. Did I copy? Boom. Clear. Make echo this guy. It's true. Right. Make build. Please work for me. To be frank, I'm not sure what the next step would be if it fails again, because I've built it several times. Yeah. Please, yeah. I think it's getting there. I think it's getting there. Another error. Successfully tagged KEDA core, KEDA metrics. Registry access Red Hat. Latest environment using cache. Step 3, copy build output. KEDA operator copy failed. Docker build output. No such file or directory. Wait a second. It's not building. Let's open the code again. The price of being on the bleeding edge. let's see. In the make file, go build KEDA operator. So it's complaining that there's nothing in this output. Docker builder, this guy, the build output KEDA, no such a file or directory. Let's see if the guys have touched this area or not. Okay. I wish I didn't change the branch of the original one. So did we change anything in the make file? Recently, scalars, master build, validation, master build, workflows. This is all workflows. Pointers, scaled objects. It's probably easier if I find this is the readme. This is not it. This is read. So why isn't it finding? Let's, you know what? I'm gonna quit this one and see. Let's see this path, or let's say before Docker. You know what? Let's check this file. Build Docker file. I'm gonna sneeze. I think it's coming. Docker file. Operator user KEDA operator. Sorry, adapter. Environment copy build from operator. This environment variable is coming from somewhere. Copy build output bin KEDA from this adapter. Let's see if we have copy. Let's open another tab. This is very interesting. It's going in a direction that wasn't planned, which is, I think, should be normal. Ah, okay. Or is this in the Docker? Again. Maybe this one. Yes, this one. Let's see if this has an output. So if we go to build output bin, we have a KEDA adapter. We do. And it's built. If it's built, oops, sorry. Let's go back. So this one exists, but what is images. Environment variable. Let's find this. Copy. Entry point Docker file. So it's here. Execute operator at. This is weird. This should be. There must be a very simple way on investigating this. Is it filling on the right place? 3 of 7. 1, 2, 3. Yeah, it's this one. No such a file or directory. Maybe it's not happy that I changed the tag. Could it be? Do we have I think the operator This also weird thing. There's also a weird thing that yeah, we are still saying that this is the latest building args. Okay, one last time. If you give me a pair of eyes from you, dear audience, that would be awesome as well. We are getting the image. Here you go. Silly. Operator environment is the user local bin KEDA. Using cache, and then copy build output bin KEDA to the operator. Aha, look, this is weird. If I check this path, bin build, yeah, build output, there's no KEDA. I think this is the change, because I tagged it with KEDA. With KEDA Ayashi, so it cannot. I shouldn't tag it with KEDA Iashi. Yeah. All right. So if we go back to where the make file, I think the make file. Where's the make file? Make file. You'll see that, of course, this should be not just the tag. This should be the whole thing. The repository, the image, and the tag. Correct? Shall we try that? But before doing that, idiot! It's this. It's this guy that we need to change. Not the image adapter. It's the image tag. Because the image adapter is always expected to be KEDA. You know, if it's always expected to be KEDA, I don't think it should be an environment variable. This is a feedback to the guys in KEDA. Or maybe we can create a pull request. Should we create a pull request right now? No. Look, I don't think we have time for that. But it would be very interesting pull request based on that. So it's either your environment variable, the whole thing, and you use it every way. So in the build script. So if I pin this file, if we go to the Docker file that we had before, I shouldn't be expecting this one to be KEDA adapter, right? This is the one that we were looking at because it's hard coded. So if I'm going to make this as an image, sorry, it's not a chat message. Okay. Let's go back to my dashboard. Okay. If I'm going to hard code this, I shouldn't make it an environment variable. Correct? I think. Okay. Now let's retract. Let's retract. I'm gonna ignore this session. Yeah. In this session the environment variable is still the same. So if I say echo image adapter, there's nothing. Beautiful. So let's go to the same path, which is source KEDA Iashi, cd source KEDA Iashi, and then we export. What do we export? Image tag. This is not how you export, Imad. This is not how you export. This is how you export. Export image tag to become Imad KEDA. Let's make sure that it's the same and we don't have a spelling, and then we make build. Are you with me? Okay. How's the quality of the stream, by the way? Ah, of course, because we didn't do the mini cube or the eval mini cube Docker environment, because the Docker CLI is still trying to use the to reach to the Docker daemon in the Docker desktop. Evaluate, and then we do this again. Make build. Yeah. So yeah. Ah, the quality is awesome. Ah, Jason is here. Awesome. Let's see. The Docker daemon is building. I think we had this stage before. Oh, what happened? Is it the same error? Step 3. It's the same error. No such a file. I'm sure we fixed it. Should I try to close the whole sessions again? And this way, because the is it building KEDA? Let's see. Yes, it's still KEDA Iashi for the did we even have a different environment variable? It's not the adapter. Which environment variable did we change? Did we have the image controller? don't think we have that changed anywhere. Equal this guy. Image adapter. Correct, because we are in step 3 for the operator. It's is it the adapter? Is it the adapter? This is the make file. We are here. The adapter. Yeah. It's the adapter. The adapter is there. This is not the adapter. Because the adapter is there. KEDA Iashi is the one. What did we do? Did we change the operator? Go image adapter. Alright, let's do it from here. Echo image adapter. Huh? The export expands decisions. How do we unset an environment variable? Any suggestions? If I say export image adapter equals nothing, what will happen? Bad assignment. What about if we do this? Bad assignment. I think I'm gonna ask Google because I'm not the best bash person ever. Let's ask Google. Unset environment variable macOS. How to unset environment? Syntax unset. Is it just that? Let's do this. If you're gonna do this here, let's do this there. Ah, here you go. Jason, thank you, Jason. Unset image adapter echo. We have to trust echo image tag. That's still imad كده. Echo image adapter. There's nothing. Make build. We make build. Now is the moment of truth, my friends. Yeah, usually they say don't stay shut in a stream. I have to keep talking. I can read the output for you if you like, but it's not gonna be convenient. Ah! Is it different? Oh no, it's not different. It's different. It's different. Copy. Failed. Now it's talking about. This is disappointing. It's the same error. Is it a little bit different? Is it a bit different? Docker. Let's see if we have at least an output. Refresh. How about we delete this? CD the lost distribution. I'm gonna delete this thing and see if it's being built. Delete. Move to trash. Okay. Make build again. I wonder if see, it's still getting this is the adapter matrix adapter, not KEDA. The tag. Yeah, this is correct. Yeah. Now we are building the image tag, not the image itself. Sending build context to Docker daemon. We have passed. We have passed a step. Guys, I think it's working. I think it's working. It's taking a little bit longer than I would normally feel comfortable, but you can see that we passed step 3. And there is a possibility that we are on the right track. And we blamed the bleeding edge. Blame myself. Oh, here you go. Oh no. What's the difference now? Oh, that one was the adapter. The adapter passed properly. Now it's a different thing. Isn't it? Or is it the same? Maybe I'm looking at the wrong file. Yeah. So we are building the image with the right tag. Blame the demo. God, no. Copy build output bin KEDA. The var lib docker temp docker builder build output bin KEDA. Why do we have such a long thing? How can I list all environment variables? I think it was print inf maybe. Is there anything that we can blame? I'm not being scientific really in the search, am I? Okay. In the make file, let's open the make file again. In the build environment, in the building block, where's build? The go build builds the output in the KEDA operator main go image adapter. The image adapter was built with the right arguments, correct? Why did it say KEDA core matrix adapter? 4. Should I try and get the commits before? Or should I prune? I can docker prune, correct? Docker image prune. Yes. I don't know if it's gonna help. Let's. I know this is not scientific. Let me just run it one last time. Print environment variables. Huh? I thought we unset image adapter. Again, unset image adapter echo image adapter print environment variables. There's no image adapter. Now export image tag equals imad KEDA. Print environment variables. Image tag now. Make build, please. Well, I'm satisfied that we are still having the same number of viewers, unless they are doing something else. No, this idiot is not knowing what he's doing. Okay. Maybe. I surrender. This is not my night. I'm not too scientific, I just can't see it. Fail to output build image something. Yeah. The step fails. I don't understand what this is really. Docker build and this thing. Variable library docker temp. Where's the Docker file? Isn't it the same? There's 2 Docker build here, correct? Oh, there's only one. One last time, let's read this slowly. We make the build, we run the build, KEDA adapter, mango, docker build this guy. This one works. Successfully built and tagged. But then it proceeds. Building OCI image. Sending build context to Docker daemon. It's removing image edit container. Could it be that I stuffed Minikube? Let's do this. Let's Minikube stop. Okay, let's just do that. Because we built the Docker image, we built the image. Step 7 out of 7 is good, and then it says built and tagged. But then it seems like sending build context to Docker daemon. Let's try to build something again. I don't know, it's building it again. So, and there's only one Docker build. Let's see. There's only one. Docker IO, Docker push. I hope we are not publishing. We're not publishing. Docker build. The Docker adapter with the tag. Yeah. Okay. Let's Minikube start. Let's say JSON. Minikube start JSON, and then what's the command? VM driver. Minikube start JSON. We are creating a new Minikube cluster with VM driver equals virtual box. I'm creating a new Minikube profile JSON. Minikube start JSON VM driver equals virtual box. Okay, now it's creating a new virtual machine. I think this is the last resort. If we are stuck on this one, I'll give it one last go before we wrap in 15 minutes. Because frankly, it's been maybe 30 minutes we are stuck in this. If we scroll up a little bit and try to understand what's going on, why is it so? Here code generation, we do this. We are building docker build -file docker file adapter -te docker image KEDA, because this is the matrix one. This is the matrix one. And this is the operator. So it's not doing it twice, it's a different one. But it keeps complaining about not finding this path. But why are we what? Why are we getting this path? Why all this path exists? So if we go there again, could that this operator is not? So this is set by operator user local bin KEDA. We are starting the server. Okay, good. Mini cube status. We have new one. Let's do this eval mini cube Docker environment variable, because we have a new cluster. Let's print the environment variables. You can see that we have an image tag. That's correct. And there is nothing weird here. So if I make build and go back to the code a little bit and see here we are. Let's find operator. Yeah, same problem. The operator is this guy, but it's insisting that I am running within this. Let's see if there is any history in this. Let me check the history. Days ago. Yeah. This has been always like this. So even if I check Even if I check the previous version, I can't see where we have touched anything regarding the Docker image. The Docker file, div container. No, it's not a div container. Master build. Make file. Did we? This is the image tag. It was yeah. It was hard coded. Now it's taking environment variables. The deployment templates. This is all the Helm chart. Okay. Where is it? Redo the last minutes. Jason, how can I redo the last minutes? It's really tough. The thing I'm totally blacking out. Like it's like I feel so idiot that this path is obviously relative to the container that's somehow it's in the container. In a container. Because if we check the result here, you see that there is var library docker temp docker builder and then the path we are looking at, build output. It's not looking in my machine. Why isn't it looking in my machine? Yeah, there's two. There's two. There's the KEDA metrics adapter. This is one. It built successfully. And then it built the KEDA image itself, which should be the operator, but failed on this output. Where is this? Okay, let's start from the beginning. We are running the code info code generation. Let's compare it to the make file. We're saying docker make build adapter and then build controller. So, I don't know which one is first. So, generate the APIs. This is the code generation part. Code generation complete. And then operator SDK build image controller, which I'm assuming is the metrics server. So if we go here, docker build -file, docker adapter, So it builds. Could it be this is doing something else? Okay. Go build here. There's no go build here. So this is there. Where is it? Go build. Yeah. The adapter. It's this one. So it builds fine. Then we build the operator based on this. So it builds it. It runs it fine. Runs it fine. 3 minutes. Builds it fine. And then removes the intermediate containers. And it says successfully tagged. Wait a second. So this step finishes and it succeeds. Then maybe the operator build the image controller. This is the adapter. Ah, yeah, this is the operator now. So it must be this thing. Image controller build. It tries to build the controller, yeah. Makes sense here so far. And then it tries. Could it be that the operator SDK is stuffing it? Go bit odds. Yeah, because we only have one Docker build, so, and the Docker build is here. So if we have another build, then the operator itself is not. Let's try this. Let's try execute this directly here. Because I'm sure I tried it before. Let's close this one. I'm not sure I know what I'm doing. Before we build this operator SDK, compiles code and builds artifacts, the image controller. So let's say Docker build, and the image controller is, let's see where it comes from. From image registry, image repo, and the image tag. So it should be exactly the same. This one is KEDA. Okay. So it's, let's take this this guy and say operator SDK build and this guy. Didn't I copy? Again. Copy. Operator SDK build. I can't even copy. I promise this is going to be the last thing. We're going to surrender for the night. Okay. Operator SDK build without the tags. Let's see what happens. Out of curiosity. Line 72. Wait a second. Failed. It's the same error. Okay, so we at least we know that it's the operator. Should the last one really be image adapter and not image controller? Line 72. Sorry, line 72. No, I think this one. This is for the metrics file, and the metrics file is for the adapter. I think the naming is a little bit confusing. But if I check this, because it's working fine. Let's see what they have in the workflow. Workflow. Is it version? Build. Deploy. Workflows. Master build. Steps. This is the jobs validate. I don't think we want validate. Publish. Make publish. Test. Make test. There's no specific environment variables. Yeah, no. So I don't think this is true. 72. No, I don't think that this is the right thing. I think it's correct. This is building. The SDK is building the controller, which is the operator, and this is the adapter, which is the metrics. So if I'm executing the operator SDK build, I think it's trying to build. I think it's my configuration. Okay, look, it's 10. It's 5 past 10. Let's try one last time. I want to force upgrade. Force install the operator, because I remember when I installed the operator, it played with Minikube for some reason. I think it was brew. Let's brew. Did I do that? I did install it. The operator. did I install it directly, or was it brew? Brew list. Yeah. Brew minus h. Brew. Can I install there again? Install operator SDK. Oops. Brew install operator SDK. Let's see. Now I remember when I installed the operator SDK, it was doing some magic with some Minikube stuff. And I was like, oh, why is it doing this? Let's now make build. If this does not work, I will apologize, but at least you have seen some of the troubleshooting that we were going through. We wasted some of the time, but at least we are one step closer to what the problem is. Hopefully this will help us for the next time, if you're gonna be next time. Yeah, it didn't work. It's the same problem. Fair enough. I think we'll have to pause here. I'll try to troubleshoot this on my time again, because I tried this several times. It worked beautifully. Today is like it's just like every other streamer. I think they brew install. Okay. Okay. Brew. Jason, thank you so much. Brew reinstall operator SDK. Let's just try this one. But it's really, if it's stuffed up, this is the last time. Really, I promise that we're gonna stop here. Yeah. Did it change anything after the install? Downloading? Yeah. Caveats. Next week I will have figured this out, and we will build a scaler without a problem. So let's just see the result of this last one. Other than that, otherwise we have to end it here. Same problem. All right. Thank you, guys. Thank you for being here. I really appreciate the time that you have spent with me. I hope that this did not discourage you from having plans to join me next week. I will figure this out, and hopefully next week we will start from a clean slate, and we have answered this question. If you'd like to keep in touch until then, please feel free to contact me on Twitter, EMADASHI. I'll be very happy to receive all your comments and feedback. Thank you so much, and good night. Thank you, Jason. Thank you, David. Thank you, whoever was there.